Now, senior, let's answer a few questions on oxidation and reduction. Just a few calculations. Here, the first question says calculate the oxidation number of sulfur in each of the following compounds. So this is number 1A. So now here you can see sulfur, what's it called? The first question is H2SO4 in A is H2SO4. Now H2SO4 means the same thing as H2SO4 0. There's no charge on the molecule, so we can assume that the charge on the molecule is 0. This means that the charge of H2SO4 is equal to 0. H2SO4 has 2 hydrogen, 1 sulfur, 4 oxygen, and if you put their charges together, you get 0. When looking for the charge or oxidation number of an element in a compound, we need to know the oxidation number of the rest before we can find the unknown. You understand? So in this question now, oxygen is always -2, except in peroxides. Hydrogen too is always +1, is always charged +1, except in metallic hydrides. It is in metallic hydrides like sodium hydride, potassium hydride, magnesium hydride, and so on, that hydrogen is -1. But in all other compounds, hydrogen has a charge of +1. So put this together, what do you get? You get 2H, 2 times +1, plus sulfur, plus 4 times -2 is 0. So +2 plus S minus 8 is 0. 4 times -2 is -8. So let me rearrange. S plus 2 minus 8 is 0. S plus 2 minus 8 is 0. S minus 6 is 0. That gives us what? That gives us S is 0 minus, that gives us X is 0 plus 6 and S is +6. So the oxidation number of sulfur in H2SO4 is what? +6. Let's continue. Question B. Question B. Okay. In question B, okay, the compound is SO4. SO2, I mean. Sulfur 4 oxide. Now, the oxidation number of sulfur and sulfur 4 oxide. Sulfur 4 oxide is SO2. There's no charge on it. So the total charge on the compound is 0. That means SO2 is equal to 0. This will give S plus 2O. SO2 is 1 sulfur plus 2 oxygens. So in this compound too, I always put oxygen in brackets so that the 2O will not look like 20. I hope you get that. So that means the oxidation number of oxygen is -2. We use that here. And that will give us S minus 4 is 0. S is 0 plus 4. S is 0 plus 4 will give us S as what? +4. So the oxidation number of sulfur in SO2 is +4. That's why we call this compound sulfur 4 oxide. You understand? Oxidation number is also used in naming compounds. That's why we call that compound sulfur 4 oxide. Here too, this is why we call this compound tetraoxosulfate 6 acid. It's an acid, but a tetraoxosulfate 6. So because the oxidation number of sulfate 6, because the oxidation number of sulfur in the compound is what? 6. Exactly. Let's continue. Question 3, sorry, on 1C is H2S. H2S. So H2S. There's no charge on H2S, so the total charge on it is 0. That means the charge of the 2 hydrogen plus the charge of the sulfur will give us 0. Hydrogen is +1. Hydrogen has a charge of +1 in all compounds except in hydrides. So it will have a charge of +1 in this compound too. So +2 times S gives 0. S is 0 minus 2. S is what? -2. S is -2. So the oxidation number of sulfur in this compound is what? -2. We call this compound hydrogen sulfide. We call the compound hydrogen what? Sulfide. And in that compound, the sulfide ion is charged S2 minus. So take note of this. Next is D. Let me be fast because it's a long exercise. Question D says, find the oxidation number of ion in FES. Ion in FES. FES, there's no charge on the molecule. So FES is equal to 0. If you put the charge of ion plus the charge of sulfur together, you get 0. Now, in this molecule, the charge of ion is plus 2. So plus 2 plus S is what? 0. S will be 0 minus 2. So the oxidation number of sulfur is what? S2 minus. That means there's a sulfide ion in that compound too, S2 minus. Let's go to question E. Question E says we should find the oxidation number of sulfur in K2SO4. K2SO4. Now, potassium, K2SO4 is the same thing as K2SO4 0. There's no charge on the molecule, so its total charge is what? 0. This means if you put the charge of the two potassium ions together with that of the sulfur and that of the 4 oxygen ions, your total answer should be 0. Potassium is a group 1 element. Its oxidation number is plus 1. So 2 times plus 1, 4 times minus 2 is 0. Plus 2 plus S minus 8 is what? 0. Plus 4 times minus 2 is minus 8. So this gives us S plus 2 minus 8 is 0 on rearranging, and that's what? Plus 2 minus 8 is minus 6. So the oxidation number of sulfur is 0 plus 6. That gives you plus 6. So the oxidation number of sulfur in this compound is plus 6. That's why we call this compound what? We call it potassium. We call that compound potassium tetraoxosulfate 6. That's 4. We call it potassium tetraoxosulfate 6. So let's go because of time. Question F says we should find the oxidation number of sulfur and potassium sulfide, K2S. K2S has no charge on it, so the total charge on it, K2S, is 0. And that means that if you put the charge of the two potassium ions together with that of the sulfur, you will get 0. Potassium is a group 1 element. Its oxidation number is plus 1. That gives you plus 2 plus S is 0. That gives you what? Plus 2 plus S is 0. That gives you S is 0 minus 2, and that gives you S is minus 2. So we call this compound potassium what? Sulfide. Anyway, sulfur has a charge of minus 2. That compound is most likely a sulfide. We call the compound potassium sulfide. Question G now. Let's go to question G. Question G is KHS. KHS. Question G is KHS. Here, KHS, the total charge on it is 0. The total charge on the compound is what? 0. So that means we have K plus H. If you put all the charges of the atoms in the compound together, you get 0. Potassium is a group 1 element. Its charge is plus 1. Hydrogen is a group 1 element too. Its charge is plus 1. Sulfur, we don't know its charge here. So plus 2 plus S is 0. S is 0 minus 2. S is minus 2. So we call this compound, it has K plus, it has H plus, and it has S2 minus. We call the compound potassium hydrogen. We call the compound potassium hydrogen sulfide. I'm going to have to squeeze it into that space. So let me rewrite so that you can see it well. We call the compound potassium hydrogen what? sulfide. That's the name of the compound. Next is H. Now, question H. Okay, S2 minus. In S2 minus, the oxidation number of sulfur in S2 minus is -2. This is a sulfide ion. We call this a sulfide ion. So that's just pretty straightforward. Next question. In I, okay, SO3 2 minus. SO3 2 minus. Now here, the charge on the molecule here, this is a radical, and the total charge on the radical is -2. So SO3 2 minus means if you put the charge of all the elements in the compound together, the total should be -2. So S plus 3 times O will give you -2. Now, that means the charge of sulfur, plus 3 times the charge of oxygen will give -2. S minus 6 is what? -2. What does that give you? S is equal to -2 plus 6. S is plus 4. So the oxidation number of sulfur in this ion is what? Plus 4. The oxidation number of sulfur in that ion is plus 4. We call this compound tri. This radical, I mean, not a compound, it's a radical. We call it trioxosulfate 4 ion. It's an anion, trioxosulfate 4 anion. Now you will notice something. We use what's it called? We use mono. We use mono for one. We use mono for one. We use di for 2. We use tri for 3. We use tetra for 4. For 5, we use penta. For 6, we use hexa. For 7, we use hepta in naming compounds. For 8, we use octa. For 9, we use nona. 9 for nona. And for 10, we use deca. You understand? So take note of this prefixes. Then J. In question J, we have to find the oxidation number of sulfur in ZnSO4. Now ZnSO4 has no charge on it, so the charge on it is 0. We say the total charge is 0. This means if you put the oxidation number of zinc together with that of sulfur, together with that of the 4 oxygens, you should get 0. Zinc is a group. Zinc is an element charged 2+. So plus 2 plus S plus 4 times -2 will give you 0. You understand? That gives you S plus 2 minus 8. Let me take it slowly because of some of us. Plus 2 plus S minus 8 is 0. What does that give you? That's S plus 2 minus 8 is 0. S minus 6 is 0. X is equal to 0 plus 6. S is equal to 0 plus 6 is X is equal to plus 6. So I will call this compound, zinc, and it has zinc and SO4 2 minus. So we call the compound zinc tetraoxosulfate 6. It's a salt. We call it zinc tetraoxosulfate 6. Number 2 now. Number 2A. The question says, calculate the oxidation number of nitrogen in each of the following compounds: N2, NaNO2, N2. Now, the total charge on this compound or on this molecule is 0. So N2 is equal to 0. That means 2N. If you put the charge of the 2 nitrogen atoms together, you should get 0. So this tells you that nitrogen has a charge of 0 in this molecule, in this substance. And B, NaNO2. Now, NaNO2 has no charge on it. I can write 0 for it, meaning that the charge of the molecule is 0, and that tells you that sodium plus nitrogen plus 2 oxygen is 0. Let me be sure that's NaNO2, okay, and not NaNO3. So sodium is a group 1 element. Its charge is +1. Nitrogen, we are looking for its charge. Oxygen is always -2, except in peroxides. Let me tell you what compound we call peroxides. Hydrogen peroxide, potassium peroxide, sodium peroxide. Compounds that look like this are the compounds in which oxygen has a charge of -2. We call them peroxides. When we get to types of oxides, we will learn that more. So this is what? +1 plus N minus 4 is 0. That gives me N plus 1 minus 4 is 0. +1 minus 4 is -3. So N minus 3 is what? 0. Exactly. That gives N is 0 plus 3. N is what? +3. So NaNO3, what will I call the compound? NaNO3. NaNO2, and we call it sodium. We call it sodium dioxo. I think you can see the reason for our di, mono, and co now. Dioxo, because there are 2 oxygen atoms. Sodium dioxo nitrate. It should be just on a single file, so don't get it confused. Let me try and write it on a single file. We call the compound sodium dioxo nitrate 3. It's a salt. We call it sodium dioxo nitrate 3. So question C now, 2C. Let's go to 2C. It says NaNO3. We should find the oxidation number of nitrogen in NaNO3. NaNO3 has no charge on it. That's NaNO3 0. The charge of the molecule is 0. What does that tell you? That tells you if you put the charge of Na together with that of, add it to that of nitrogen plus 3 oxygen, you should get a total of 0. Nitrogen, sodium is in group 1. Its charge is +1. Oxygen is always -2, except in peroxide. This compound is not a peroxide, so oxygen will be -2 in it. That's -6 is 0. That gives you what? N plus 1 minus 6 is 0. N minus 5 is 0. N is 0 plus 5. N is what? +5. Now, if you have N as +5, NaNO3, what do we call the compound? NaNO3. We call it sodium. We call it sodium. We mostly read our cations first. Sodium trioxo. You can see 3 oxygen atoms. Trioxo nitrate and nitrogen ion. Trioxo nitrate what? 5. It's a salt. So take note of how we use oxidation to name inorganic compounds. D now. That was question C. Let's go to D. NH4 plus, NH4 plus, NH4 plus. What's the oxidation number of nitrogen in NH4 plus? Now, NH4 plus means the total charge of the radical is +1. Plus is the same thing as +1 or 1 plus. So, in chemistry, they have funny ways of writing that. So that means if you put the oxidation number of nitrogen together with 4 hydrogen, you should get a total of +1. Now, this is not a metallic hydride, so the oxidation number of hydrogen here will be what? +1. Hydrogen has an oxidation number of +1 in all compounds except metallic hydrides. So N plus 4 is +1. N is +1 minus 4. That gives you what? N is -3. So we call this, we simply call this ammonium ion. Some have special names that don't follow, the patterns Don't follow the pattern we use in naming other compounds. That was the inner or radicals. Inner ammonia, NH3. NH3. There's no charge on the molecule, so the charge of NH3 is what? 0. Now, 0 means that if you put the charge of nitrogen together with the charge of 3 hydrogens, you get a total of 0. Nitrogen, we don't know its charge. Hydrogen, we know its charge. So hydrogen is always +1, except in metallic hydrides like NaH, KH, and so on and so forth. I think I said that earlier. So that means N plus 3 times +1 is +3 is 0. N is equal to 0 minus 3. N is -3. So what does this give you? -3. We call this compound ammonia. So we simply call it ammonia. That has a special name. F now. Okay, let's continue very quickly. F is what? Aluminium NO3 2. F is Al2NO3. Aluminium NO3 3. It should be 3. So here, there's no charge on the molecule, so we can write 0 on it. NO3 0, meaning that the charge of Al NO3 3 is total charge is equal to 0. Now let's spread out the compound. There's 1 aluminum there. There's 3 nitrogen. I'm using these 3 to multiply the nitrogen here. So there's 3 nitrogen and there's what? 9 oxygen. You understand what that means? 9 oxygen. 3 inside the bracket times 3 outside gives you 9. So Al plus 3N plus 9, 0 is what? 0. What does that give us? Al, aluminum is a group 3 element, so its charge is +3, +3, +3N plus 9 times -2 is 0. So +3, +3N minus 18 is 0. That's what? 3N plus 3 minus 18 is what? 0. That gives you what? 3N. That gives us 3N. That gives us 3N minus 15 is 0. 3N is 0 plus 15. That's what? 3N is plus 15. N is plus 15 over 3. N is what? Plus 15 over 3. N is plus 5. So the oxidation number of nitrogen in the compound is plus 5. We call this compound aluminium trioxonitrate 5. We like to keep that 5 in bracket. Okay, that was what number? F. Let's go to G, N2O4. G, N2O4. In N2O4, there's no charge on the molecule, so N2O4 is the same as N2O40, meaning that the total charge of the molecule is what? 0. If you put the charge of the 2 nitrogens together with or add it to the charges of the 4 oxygen atoms, you get a total of 0. So 2N plus 4 times minus 2 is what? 0. 2N minus 8 is 0. 2N minus 8 is 0. 2N is 0 plus 8. 2N is plus 8. And what? 2N is plus 8. N is plus 8 over 2. And N is what? Plus 4. So the oxidation number of nitrogen in this compound is plus 4. N2O4. We call it dinitrogen what? oxide. We call it dinitrogen 4 oxide. Dinitrogen because there are 2 nitrogen there. You understand? Because there's another compound NO2 called nitrogen 4 oxide. There's another compound NO2 called nitrogen 4 oxide. So we try to distinguish between the 2 oxides of nitrogen having the oxidation number of nitrogen as 4. We try to distinguish between them by writing dinitrogen 4 oxide for this one instead of just nitrogen 4 oxide. So take note of that. H. Question H now. That was G. Question H says N3 minus. That one is straightforward. N3 minus. The oxidation number of nitrogen in this ion is -3. We call this nitrite ion. We call this the what? Nitrite ion. I is N2O. There's no charge on N2O, so we say the charge on it is 0. If you put the total charge on it is 0. That means the charge of the 2 nitrogen plus the charge of oxygen. There's 1 oxygen and 2 nitrogen atoms in the compound. Their charges we add to give you 0. So 2N plus -2, which is the charge of oxygen, in all compounds except in peroxides. 2N minus 2 is 0. 2N is 0 plus 2. 2N is 0 plus 2, so 2N is what? Plus 2. N is plus 2 over 2. N is plus 1. So the oxidation number of nitrogen in N2O is plus 1. And we call N2O dinitrogen. We call the compound dinitrogen 1 oxide. I hope you can see the pattern here now. We can see the pattern. You understand how we use our prefixes di, tri, mono, and the reason we use it. So that's question I. Then J, Mg3 and 2. Question J, which is the last question in number 2. Okay. J, let me change my marker. Mg3 and 2. There's no charge on the molecule Mg3 and 2, 0. Meaning that if you put the charges of all the atoms in it together, Mg3, 3Mg plus 2N, you should get 0 as your total charge. Magnesium is a group 2 element, so its oxidation number is plus 2. 3 times plus 2 plus 2N is 0. This gives you plus 6 plus 2N is what? 0. That's what? 2N plus 6 is 0. 2N is 0 minus 6. So 2N is minus 6. N is minus 6 over 2. From N is minus 6 over 2, N is minus 3. So the oxidation number of nitrogen in this compound is minus 3. We call the compound, simply call it magnesium nitride. Magnesium nitride. Now, this is a nitride ion. Present in a compound with magnesium ion. So we simply call the compound magnesium nitride. I hope you get that. So I will be, we will do number 3, question 3 here in the next video. But before I send it to you, or before we touch that, I want you to try it yourself. Try to find the oxidation. Question 3 says calculate the oxidation number of chlorine in each of the following substances. Sorry, this is not showing too clearly, but I believe you can see it here now. So try the number 3 yourself before we actually do it together. So let's rest here for now.